Hi everyone, welcome to the Altium custom parts tutorial. Finally, I'm Jonah and I'm joined by Chris,
Hey, what's up?
and we're going to be discussing, surprise, how to create custom parts. So we've taken a little while to make this tutorial, and that's because we wanted to show that you can do a lot of things in Altium without having to make custom parts. However, many STP projects require them because it's a piece or circuit that you need that makes your part special. So we're going to go through two components in this tutorial to show you the basic workflow of how to make a schematic symbol, and then in the next video, we're going to link it to how to make your footprint. So, Chris, do you have anything to add?
Well, why is this the last tutorial? Why did we put this off for so long?
Uh, because you can do a lot with Altium without having to make your own custom components. You can use a manufacturer part search, which generally has pre-created components, footprints and symbols, that have not only been vetted, but have been tested on PCBs. And they're likely to do a much better job than uh, someone can do at home because they'll have the time and effort and they're being paid to produce those footprints. Making footprints is very riddled with errors. It's error prone. There's a lot of small details, and often data sheets are hard to read. So if someone else has already done the job and tested it, use their work again. Save you time.
That's right. The more complicated the part is, the more you really need to be on your game to not make a mistake in both the schematic symbol and footprint part of this process. So let's start, nonetheless. So there's two ways to start, really. So you can use an integrated library within your project group, or you can create a actual library that's specific to a project. And I'm actually going to do the latter, although I would recommend that a lot of people consider the former to see if that makes sense. If you're doing multiple projects, or you think you might be using these parts for other projects, it's a good idea to just have an integrated library. And I would go to File, and I would go to New, whoops, File, New, Library, Integrated Library. And then that stands by itself. Here's an example. I have a master library, and all of these projects within this project group can access it. But I am aware that a lot of teams really are just doing one project, and that's okay. Another way to deal with that is to right-click on your project, add new, and then just do a schematic library. And that's where we'll start. So once you hit the save button, Altium's going to want you to name it. Let's just do that. And I'm going to call this schematic library 1.
I'd suggest a more
And there it
descriptive
is.
library title for your parts, but this is a tutorial.
Yes, right. This is a tutorial, and we're not going to probably end up using this library for much else. So what's the first part we're going to do? We want to keep it simple on the first part. We're going to do a neopixel, and this particular neopixel is a weird shape. It's a 3535, which means that it is 35, is that 3.5 by 3.5 millimeters?
I believe so.
Right.
You can purchase these on Adafruit, which is where we found them. Often, if you're buying custom components, you might not get the best documentation. And this is a good example of that. All we have is a diagram and no real footprint layout.
Right, so a lot of data sheets will give you something called their suggested footprint layout or suggested footprint or something like that. And if they give you one of those, you should, read it and refer to it when you're designing the parts. But this one doesn't. This one doesn't give us a whole lot to go off of except for what the back looks like. But we're not going to worry about that right now because obviously we're going to do the schematic symbol first. So what's the difference? The schematic symbol does not need to necessarily represent the part on any physical level. It just needs to have the same inputs and the same outputs and descriptions of all of those things so that you can use it in a schematic. So what would that look like for a part like this? Let's start by just making the general shape of our part. I'm going to hold down the line tool till I have this rectangle, and then I can place the top left corner and the bottom right corner, and I'll resize those later, but I'll just make them extra big for now. And then so here is our square. And I can do more with the square if I want to. Maybe, for an LED, I might put a circle on it or something. There, that's like the lens of the LED. I don't know. You can get creative here, make something that's descriptive and helpful. That's a good idea. And before we go too far, we want to make sure that we put in some, preliminary information. So design item ID is going to be the name of the part. So I'm just going to call this one NeoPixel 3535. Obviously, this is not the part name of this part. You should use whatever is like the DigiKey name or something shortened and make it easy to read. Then we're going to give it a designator. So a designator, you should know what that is right now from your schematics. Obviously, you have R for resistor, C for capacitor. There are standards that you may or may not want to refer to. For this particular part, I'm going to go LED, and then I'm going to add a question mark, which Altium will later fill in. That will allow us to use the automatic annotation tool later. And then a comment is a good idea. Comment's a good place to put a couple more specific descriptions of your part. So I might put maybe like a part number in here or a value if this is some sort of passive that has a value. So for this comment, I am going to put SK6812 mini. And then finally, there's your description. And the description can be anything you want it to be. I would recommend some information about where you can get this part, or some maybe like the DigiKey manufacturer part number would be a good thing to copy and paste into there. Then the last thing I want to do is just quickly mention a link. So right now you can see it says no links on this bottom. So if I go to add, I can go to add link, and then I can actually put in a DigiKey link for where to find this part. That's a good idea so that you can refer to it later, or maybe like an Adafruit link or something like that, and you can just copy and paste it right into this field. And you can name that instead of new link, you would call that like, I don't know, supplier link or something like that. So we're going to add some pins. So maybe you saw there are 4 pins on this part. There's data out, VSS, data in, and VDD. Okay.
Chris,
So let's do those.
may I suggest point something out and suggest where to put the pins?
Sure.
So, because we don't need to have our schematic reflect the physical layout of our chip, why not lay out our schematic symbol in the way that is most convenient for routing our schematic? So, NeoPixels, we chain them together with the data out of one into the data in of another. So, a convenient way for this kind of SC would be to have data out on one side and data in on the other, and then power on the top and ground on the bottom. And this is something you can do with other ICs as well. You'll have to look at
That's a
how you
great
want to
idea.
organize them.
So without having to delete or change anything, I'm going to adapt my drawing to make sense in this way. By the way, if you're doing some drawings and let's say I want to make this circle smaller, that's going to be hard because my grid snap is 100 mil, which is one box. But I can change that if I hit G, just like I'm in the PCB editor. Now you can see in the bottom left, grid says 50. I can move this a little smaller. Now I'm doing 50 mil increments. Okay, so let's do what Jay just said. That's a great idea. Let's have our data flow from left to right, I think. So what will that
Agreed.
mean? So here's our pin button right here. If you're messing around with the grid size, you want to make sure that this X right there, you can see, ignore the mount 5 for now. This X right here is on a intersection of the grid lines because that'll make it easier to connect to later. So I wouldn't put it here. That would be a poor choice. Let's put it
Maybe
here.
even
I'm
switch
gonna
your
hit.
grid snap back to standard so that you can't mess it up.
That's a great idea. Yeah, I'll hit G again and it'll switch to that. So I'll hit Tab, and then I can pull this out and I can set some properties. So this is going to be the designator. We're going to have it be 1, and then the name. And if I look at the data sheet, this is D out is pin 1. Okay. And then I have to choose an electrical type. So we're going to call this an output because that makes
Yep.
the most sense of the choices we have. Whoops. And then to pin length, I'm actually going to set this to just 100 mil so that it only is the length of one grid line. And then I'll use the space bar, press twice, and there we go. Our data out is flowing out to the right. So that would be our left to right flow. And then
Pin
likewise,
2
um,
is VSS.
yeah, pin 2 is next. So if I actually go to place another pin, Altium will, if it notices a number in the designator or name, it'll increment that number, which can be helpful or annoying depending on what you're doing. Right now it's helpful. Pin 2 is VSS, and VSS, we're going to set this to power. And I will do this. And then pin 3 is data in. So let's do this. I'll hit tab again. I will set this to D in. And
Oh,
then pin
that should be
4.
an input, right?
Oh, you're totally right. Let me place this pin 4 before I forget. Pin 4 is going to be VDD. And that is correctly a power.
So,
Let's right click to cancel, go back here, and then we can go to input.
what are the advantages of setting the uh, designator type? Is that what it's called? The power and input output. Why do
Yeah,
we
that's
set
a good
those?
question. So we don't necessarily have to set those. You could have them all be passive or something, and then Altium wouldn't really worry about them, and you wouldn't either. But it's not a great idea, because if you set them to what they really are, then when you go to validate your PCB, or sorry, when you go to validate your schematic, Altium is going to make sure you didn't make some silly errors. For example, if you connect two outputs together, you're going to get an error that tells you that you did that. If you connect two inputs together with no output on that line, you're also going to get problems. So there's a bunch of things that Altium checks for, and it basically keeps you from making a silly mistake later. So there's one thing I want to change with what we have right now, and what that is I'm going to select all of these, and I am going to go to this eye icon and hide those. And I'm going to click this eye icon, and wow, that's all right. Don't worry, we'll fix it. So I don't necessarily need to see the 1, 2, 3, 4 right now. Those are helpful numbers, but maybe when I'm designing a schematic, I don't necessarily care what pin is pin 3. That would be more helpful on a PCB, which is not what we're working with at the moment. What I'm going to do first is I'm actually going to move these to the side so we can see them, so you can see what I'm talking about when I do this. And right now you can see my grid is set to 10. I'm going to hit G so it's back to 50 actually. And let's just put these just to the side like this. So this one is going on the bottom, and this one is going on the top. Okay, so what can we do? Obviously, these letters are too big for our symbol. I could increase the size of the symbol, and that's fine, but obviously, the more you increase the size of your symbol, the more space it's going to take up on your schematic. With a part like this, you might have a lot of them all in a chain, so it might not be very convenient to do that. So I have some other options. So one option is to take this, let's just make it a little bigger. And you see that I'm actually again, I'm in a 50 mil snap. I'm going to get rid of the circle for now, maybe we'll add it back in later. And I am going to select all of these pins so I can edit them all at once. Altium is aware when you select multiple items if they're the same type of item. So because these are all pins, I can do things to them all at the same time. For example, I can set all of their lengths to 50 mil. Alright, what else? I can set all of their, so if I go to name, I go to custom settings and check it, I can actually set their names to be smaller, which will save me a bit of room. So let's start there. Now I'll move these back. Again, we still have a problem, don't worry about it. We're going to work on it, but at the very least, our pins terminate on grid intersections. So let me select all of these. Whoops. Select all of these again. I didn't mean to unselect them. And I want to go to custom position, so I'll check that. And then I can set their position. And I'm going to set this to a negative number to move the labels closer to the pins. Let's do negative 30. It's a little too much, but it is the right idea. Maybe negative 20 will be a better number. Yeah, we're getting there now. Something like that. And I believe I can actually go onto these, and if I hit orientation, set it to 90, now that will rotate those. So that might look a little more natural, like that. So now this part takes up the same amount of room, but it's not quite so huge. I mean, the labels are not quite so huge. And I'm going to put that circle back because I liked having it there. So I can set it maybe this big by this big, and that's okay. All I need to do is hit M for move, and then I'm going to say send to back right there. Send to back. And then again, I'm going to do that to the rectangle. Send to back. This rectangle. Cool. So that's one way to do it. And then I can obviously change the color of all of these things if I want to. I can get rid of its border. So maybe I will say small or something like that. Or I can set it the same color maybe as everything else. I'll leave you to explore these options. They're pretty self-explanatory, and you can make yourself a nice custom part. But for now, I think this is a good beginning. So I'll hit save, make sure this is in there, and now you can see here's my part right here. And I could begin using this on a schematic sheet. I could not begin using this in a PCB because we haven't made the footprint. Like I mentioned, we'll do that next tutorial. So I'm
As
going
a
to make one
quick,
more part in this
as a
tutorial.
quick reminder, often we don't need to make such custom precise things. If you're making a generalized um, schematic symbol, often you can just use the standard layout. But in this case, we know we're using them for this particular application, so we're optimizing the symbol to make our own lives easier.
Right. Cool. Let's make one more part. I'm going to hit add, and then our next part is going to be just this TMC, I believe it's the 2310-LA. It's a motor driver that I have some experience with. I should make sure I get this out right. 2130. Whoops. 2130. Let's make sure we get it right. Okay, and I like this part because it has a lot more pins and it's a lot more complicated. But that doesn't necessarily mean that its schematic symbol has to be more complicated. So let's hit G, and then we'll get back to the 100 mil snap, and then hit rectangle. And let's just kind of guess at the size of a rectangle. You don't have to do the rectangle first. I like to, for whatever reason. I just like having it there and kind of using it to decide how I'm going to arrange my parts. So this package is a QFN package. It has 36 pins, and laying them out is going to kind of be something we need to think about because certain ones belong next to each other and certain ones make more sense to separate. As we mentioned before, you can lay out a custom part with all of its pins kind of in the same place that they are on the physical IC, but it doesn't usually make a lot of sense to do that, and it can make your schematic look a lot messier and more complicated. So in general, we recommend kind of organizing your pins in an order that makes sense. What that does mean is that you need to keep the designators in their correct order. For example, I can't change the numbering so that the numbers go from 1 to 36 and each number doesn't line up with its actual pin designator in the data sheet. Hopefully that becomes more clear in a second, if that's not clear what that means.
So why don't we
Let me find
start
the
by
table.
placing all the pins, and then after that we'll put them into groups. How does that sound?
Right. Sounds good, and I found what I was looking for to explain that last point a little better. Here is the chip that we're doing. I could draw a rectangle that looked like this and place all the pins 1 through 36 in the same order as you see them right here. But it wouldn't make a lot of sense because you can see there are some pins, for example, BRA and BRB should be next to each other in the schematic. So I might save myself some time and trouble by just putting them next to each other right now. But I need to keep, BRA labeled 33 and BRB labeled 14. So let's see what that means and what that looks like. So I'm going to hit tab again. I'm going to go in, my designator, I'm going to start from 1, of course. And then the name of this pin is CLK. And this is going to be an input, I believe. And actually, a lot of datasheets are going to tell you exactly what they are. So if I pull up this datasheet again, you can see signal descriptions type DI means data input. DIO means data input output, obviously. And you'll see there's a couple other ones. Analog input. Yeah, and some of these are obviously power. So we're going to go through this process. We're probably going to time-lapse this because it's a little bit repetitive, but let's see maybe the first couple. So yes, the name is CLK. I'm going to actually show that, and I'm going to place it. And my recommendation to you is when you're beginning, go ahead and place them in order from top to bottom because it'll help you kind of not make a mistake. So I'll just go from 1, 2, 3, going down, and I'll reorganize them as I was mentioning after I've finished. Alright, so we just finished naming all of these pins. Let's start thinking about how to lay them out, and also I want to show you a couple other things you can do. So let's start there actually. So what are some things we can do? First of all, we can add some descriptions to these pins. It's a really good idea to do this so that you can make sure that you didn't mess anything up. So let's, for example, go, what's a good pin to do, you think?
I
So
think
some of these pins need
VC.
capacitors.
Yeah. Um,
V
VCP pin 29. It requires a 100 nanofarad capacitor to VS.
So in this description thing, I can say requires 100 nanofarad cap to VS. Okay, now that's in there. So if anybody goes to click on this or look at the properties of this pin, they're going to see that message, and that's really important. Another thing you can do, for example, is maybe I go to this AN IREF. This is my only technically analog pin. It's the reference pin, and I can give it a different color. So maybe if you have a chip that has a bunch of analog inputs, you can give the analog inputs their own kind of color, so you can see very quickly what's analog, what's digital, what's power, things like that. It's just a good idea, maybe for organization. All right, so with that out of the way, let's talk about how we're going to arrange this. So clearly my rectangle's not nearly big enough, and it's got to be way bigger. Um, Now I can choose, am I going to use two sides or am I going to use all four sides? I think I'm going to try and use two sides. I like the way it looks a little better. So obviously this is going to be pretty tall.
And
And
generally,
then let's think
two-sided
about,
symbols will lead to cleaner schematics.
right, with the exception maybe of our LED use power and ground on the top and bottom.
Yeah.
Right. So what am I going to do? So the first thing I could do, maybe, I'm not going to think about this too much because, I just want to give an idea of what this process might look like. It's going to depend on your chip. Maybe I'll put, so these are our motor coils, right? OB1, OB2,
I'd say the first step
oh wait,
everyone should
one.
do is put all the power pins together. I tried to
That's a
put
good
them on the
idea. Let's do
top
that.
left of my chip. Sorry, not my chip, my schematic symbols. My
Right.
bad.
So here's 5 volt out. Actually needs to go over there as well. I just happen to know. VS needs to go there. VCP, I think. You can check me and see if I'm wrong on these. I'm just going
I'd put
relatively quickly.
VS near the top since it seems like it's a pretty critical power one. So what I'm doing here is I'm using
Right.
the most important pins and putting them near the top. Also put pins that have the same name near each other in numerical order.
So I know there is
And
a
then any pins that
this one.
need bypasses to ground should also go near each other. And then all the ground pins should go below those. So important power, things that need bypass to ground, and then ground. I would put those
Right.
in the same section, but maybe you add a little bit of space in between them.
The ground pins.
Um,
Sometimes I put my ground pins on the bottom right and just draw them all to ground.
okay. May I suggest putting
That's just,
the two power ground Ps together,
yeah, it's a good idea. Let's do that.
and maybe 12 before
Uh,
24?
and these actually need to get rotated. Remember these, this little termination point needs to be sticking out. That's where the wires connect.
Um,
Which pin?
you have 12 under 35. Generally, you want to have them in as descending order.
Yeah, it's a good idea. Whoops.
Does it affect your final product? No. Will it make your schematic look more professional? Hopefully. And those might be the small things that people notice in CDR if you don't. Okay.
My diags are gonna go here. I think thinking ahead a little bit to what I remember about this chip. I remember we should probably put our config pins in order. That might be nice. So here's config 1. Oh, it looks like I wrote uh,
Oops.
3 twice. So let's fix that. Let's click on this pin right here. And I
Config
believe this is
2 is on pin
2.
3.
Yeah. Config 2 is on pin 3. Whoops.
Yep.
Config 2. Cool.
And there's some
3.
other configs,
Here's.
right?
There are. They are related but a little different. These basically act as SPI lines. Like
Now,
that.
I
These are
noticed
kind of.
the DCEN and DCIN pins relate to DC stepping. Should those be near the DCO pin, even though the DCO pin is not a config pin?
Yeah, that might make sense. I mean, obviously, if someone asked me that question in any other setting, I would go to the datasheet and check that, right, and come back with a real answer. But for now, since we're just moving through this tutorial, I would agree. I only say that because I hope that people actually don't guess when they go to make their schematics.
Mhm.
Uh, so let's put our power things over here. Descending order would be smart. And, well, I know that VCCIO and 5 volt out actually do not get connected. What gets connected is VCC and 5 volt out, I believe. I think so.
When you say connected,
Yeah, through a resistor.
oh, let me
Oh, your audio just cut out for me. I'm going to continue going while you sort it out.
can you hear me?
I can hear you now.
Awesome. Let's reference the datasheet for 5 volt out. Okay. Output of internal 5 volt regulator attached to 2.2 microfarad or larger ceramic capacitor near it to analog ground. So it needs a 2.2 bypass to analog ground. So I'd put it near either analog ground, although we're not doing that for this symbol. So it'll be one that requires a bypass. I'd put it at the bottom of the stack. Does VSA require a bypass?
Maybe I'll do your idea and put the grounds over there too, since there's going to be so many
VSA
capacitors between
is
them.
tied to VS, so I'd put VSA under VS.
VSA under VS.
I think people are getting the general gist. Go through the data sheet, see what pins are related, and then organize them accordingly. Do you want to fast forward through the
Exactly.
rest of this?
Yeah, or I'll just, kind of close this out and just finish this up, and, I'm not going to think too hard about where the rest of these pins go, because that is not the point. So I'll just put these here for now. It's kind of like setting up some code or something like that, where, you might be able to get code to work if it doesn't look pretty or something like that, but really, just why waste your time? Do a good job setting things up, make it look clean, give it comments, make it, something that you can use in the future or someone else can use in the future, and you'll be glad and you'll save time.
Group,
And you'll make less mistakes.
yeah, group related functions together, separate things into modules.
Exactly. So let's say that looks pretty good. Cool. What did I not do? Very important. Before I go, I need to make sure I'm not selecting anything. Uh, just click on this. I need to go to properties, and I need to go to, whoops, right here, properties. I need to set a designator. Of course, for a chip like this, I'll just use U question mark
That
for
is,
my comment.
that's the standard designator for ICs, right?
Yes, 2130-LA, and I might even write QFN because the layout is different in the TQFP version, and I would probably do a description in other settings, and I'll hit save. Cool. Okay, let's close this out now that we've done that. What can we do? We can go back to our schematic, and if I go to panels, components, give it a second to load. There it is right there, schematic library. So because I saved that, I now have access to it in other schematic sheets in this project. So I can just right click and I can place, and there it is. Cool. But it doesn't have a footprint, so I can't put this on a PCB yet. We will get to that in the next tutorial. Thank you for joining us. Let us know if you have any questions, and take care. Best of luck.